Flack math! Give me some math and I'll give you some flack. Flack math!
All right, we are at number 8. I'm so sorry that we didn't record the first 7. Number 8, find the roots. So we're going to get everything over on one side with 0 on the other. There's no greatest common factor. So we skip right to part 3 and look for a factorable trinomial. Okay, the only thing that equals 3x squared is 3x and x. And really the only thing that equals -2 is 1 times -2 or -1 times 2, or order matters this time. -2 times 1 or 2 times -1. So which one do you think it's going to be? Can you do that in your head? You don't have to. These are more difficult because that question doesn't work. What two numbers multiply to get 2, but then add to get 5? You can't do that because of this 3. When you FOIL it out, one of those gets multiplied by 3. Okay, so the question to ask is what two numbers multiply to get -2, but add to get -5 after you multiply one of those factors by 3? That's a more complicated question. So let's just try all the different combinations. What do you want to try first? -1, 2, 1, -2, 2, -1, or -2, 1? Which one do you want to try? Give me something.
-1, 2.
-1, +2. So when I FOIL this out, I get 3x squared. I get 6x, -x, -2. That combines to +5x, which is close. So that just means I need to switch these signs. So now I'll get a -6x and a +x, which will come down to a -5x. Okay? So you just have to, it's too hard to figure out in your head with a magic question. So you just have to try it. There is a Saxon way where they have to multiply this together and then they find it's weird. I think it's more complicated. It's easier just to trial and error this. Okay, so this is our factorization, but it says solve. So what x's will make this 0? Let's start with this one. What x will make this 0? +2. What x will make this 0? What do you multiply by 3, add 1 to get 0? Negative. So if it's -1, you'll get a -3 plus 1. So what will make this -1? -1/3. If that's confusing for you, just set this to 0. 3x plus 1 equals 0. Solve for x. 3x equals -1. Divide both sides by 3, and you got your answer. Okay, the shortcut is this number over this number. Opposite of that, this number over this number. Opposite of that, this number over this number. That works too. Okay? That's number 8. You can also solve using the quadratic formula. That works every time. But the trick is remembering the quadratic formula, which on these tests, you can just have that available if you want. All right, number 9 is find an equation for the inverse, okay? First step to find an equation for the inverse is swap the x's and y's. X equals 3/4 y plus 7. You see what I did? Step 1, reverse the x's and y's. Now I have to solve for y. How do you get rid of 7 and 3/4? What do you do first? Let's get rid of 7. So far, so good. Now what? Divide by 3/4, which is, you can copy dot flop. So then you get y equals, let's see. So it's 4/3 times x minus 7. You can do that. So distribute that. So 4/3 x minus 28/3 equals y. So there is your inverse equation. Okay, so dividing by a fraction, copy.flop. How we doing? Number 10, a baker is making pastries to sell at a fair. A small pastry costs $1.50 to prepare. A large pastry costs $2.50. Okay, so this is the one that we skipped. Yep, so this is the one we skipped, so we're going to skip this. Finding the limits. Yeah, if you want it to be, if you want to do it for extra credit, you can, but.
Can you check the answer just so I know?
Oh, so if you got it right, yeah.
I don't think I got it right.
All right, what'd you get?
150 small and 50 large.
Yep, that's right.
Really?
Good job.
Okay. It's easier than it seems.
But what about the constraints? That's what I was confused about.
Oh yeah, I mean I didn't pay attention to that. If you scroll down a bit, it says like constraints.
Yeah.
Because I got the 50 and 150 right.
I don't know what all that means.
Yeah, so that's it. Yeah, that's why these are confusing. So don't worry about that. And I'll give you extra credit if you just tell me how many small and how many large or whatever. Okay? All right, number 11. Solve the system of equations by substitution. All right, we just did this in Algebra 1. So first step is to get one of these variables by itself. The easiest one to get by itself is that bottom y, because it doesn't have a coefficient. So always look for the most vulnerable one to get by itself, okay? So then you have positive 5x over on this side minus 15. See what I did there, that first step? I just got that vulnerable y by itself. So now I can plug this in for y right there. So 3y minus 4x equals -1. You guys remember doing this?
Mm-hmm.
Okay, so now simplify and solve. What is that? 15x minus 45 minus 4x equals -1. Combine like terms. 11x minus 45 equals -1. Add 45. 11x equals 44. X equals 4. So if x equals 4, you can plug that sucker in right there. So y equals 20 minus 15, which is 5. Make sure it works in this equation. 3 times 5 is 15 minus 16 is -1. It works. Okay? Solve by substitution. Technically, you could just try to think of integers that would work and don't stop until you get it right. There's nothing wrong with that. You'll waste a lot of your life, but you might get lucky and get it right the first time. Okay, number 12. I'm going fast, but knowing that I'm recording this, or at least I am now, you can always go back and look, and if not, then message me and we'll figure it out, okay? 12, f of x equals 3x minus 7, g of x, blah, blah. So find f of g of x. F of g of x. Well, g of x is x plus 2 parentheses squared. So what's f of that? Well, f of that is going to be to multiply it by 3 and then subtract 7. Okay, so see how this is, I'm just plugging g of x in for the x of the f function. So this is still 3 times whatever I plug in minus 7. Well, what I'm plugging in is a g of x. So now we just have to simplify this. Okay, remember the shortcut for squaring a binomial? It's okay if you don't, but it's not x squared plus 4, right? X plus 2 parentheses squared, you have to FOIL that out. So you get 3 times x squared plus 4x plus 4, all minus 7. So that was me foiling it out. You can do that if you want to. X plus 2, x plus 2, x squared plus 2x plus 2x. That combines to 4x plus 4. So now distribute the 3. 3x squared plus 12x plus 12 minus 7. Those are the only like terms over there. So f of g of x is 3x squared plus 12x plus 5. That's f of g of x. Okay, moving on. Determine whether the probability of experiment is a binomial experiment. If not, explain why. Oh, that's an investigation. Extra credit! Yay! Did you do this one? Anybody?
Yeah.
So the extra credit, you're going to have to work for it, but you can do it for extra credit. Look at investigation 5 and see if you can figure it out. Okay? No pressure. You don't have to do it. But one less problem, which is nice because I still use the same grading scale. So each problem is still 5 points because there's 20 problems, right? So out of 100%, each problem is 5 points. So really you're down to 18 problems. So that's you just got basically 10 extra points. All right, number 14. Find any values of x which are undefined. Okay, so all we have to do is factor the bottom. Okay, there's no greatest common factor, but this is that same scenario where you just have to trial and error, right? And the only thing that equals 5x squared is 5x and x. It's nice because that 5 is a prime number. If this was like a 32x squared minus 38x, you'd be there for a while trying to figure it out. Okay? So let's just start thinking of factors of 21 that add to get negative 38 after you multiply one of them by 5. Well, first of all, you can make it a shortcut. And since the last term is positive and the middle term is negative, that means your two factors are going to be negative. So it's going to be minus minus. All right, now what's going to work?
Equal 38?
Yep.
Okay.
Not a lot of factors of 21. What are the factors of 21?
3 and 7.
Okay, is it 3 and 7 or 7 and 3?
Oh,
Okay, so if we do 7 and 3, we'll get 15 and 7, right? So negative 15 and negative 7x is negative 22x. So let's try 3 and 7. Then we'll get negative 35 and negative 3. Negative 38. See what we did? So the only thing that'll equal 5x squared is 5x and x. Okay? You're half done. And since the last term is positive, that means it's a positive times a positive or a negative times a negative, right? And since the middle term is negative, it's going to be negative times a negative. So then you just have to say, okay, what are the factors of 21? Let's try them all in my head. 1 and 21, that's like 21 times 5 is 105. That's not going to come down to 28 or go up to 38. Okay, so 21 and 1 doesn't work. 1 and 20, 21 and 1 doesn't work because that's 21 plus 5 is 26. That was kind of close, but not it. 3 and 7 or 7 and 3, that's what you come down to. So try them both until you get it. How do you know if you get it? FOIL it out. 5x squared, negative 35x, negative 3x, positive 21. That works. So what x's are bad?
7.
7. Remember the shortcut?
It's just, isn't it the opposite?
Yep, opposite of that.
Numbers, so x cannot equal positive 3.
It's this number over this number.
Oh, no.
So over here, yes, it's the opposite of that, but technically it's the opposite of that divided by that. So it's 3 over 5. If that's confusing to you at all, remember, set them both to 0. 5x minus 3 equals 0. X minus 7 equals 0. This one's easy. That has to be 7. But this, if you forget the shortcut, don't sweat it. Okay? Do that 3 more times and then you won't forget the shortcut. All right, number 15. Identify the slope and y-intercept of this line. Okay, well, how do you find the slope and intercept of a line by just looking at the equation? What do you have to do first? Yeah, if you get y by itself, that gives you all the secrets of the line. So get y by itself. I'm going to get that 4x over there first. So I'm left with negative 3y equals negative 4x plus 12. So far, so good? All right, now how do you get rid of that negative 3? Divide by negative 3. So divide both of these terms by negative 3. What's a negative divided by a negative? Positive. So this is 4/3 x plus negative 12 divided by negative 3 is negative 4. So what's our slope and what's our intercept?
Slope is 4 over 3, and the intercept is negative.
All right, so there's the slope, which equals rise over run. So you're going to rise 4 and run 3. But this is where you're starting it on the y-axis. So if I graph it, real rough, like 1, 2, 3, 4 down on the y-axis, and then up 4, right 3, right? Go up another one. Makes a straight line. There you go. Okay, 2 steps. Get y by itself so you can identify the slope and intercept. Once you do that, then you can graph it. If you forget how to graph using slope intercept, you can just pick some points that work. Okay, 3, 0 works. 0, negative 4 works. Okay, you could pick a bunch. Like 4 times 5 is 20. That's annoying. 4 times 6 is 24 minus 4. So 6 and 4 work. Okay, that's what we just graphed there too. So you don't have to graph it using the slope-intercept form if you forget that. But that is part of your question. But you can just scrap that and just graph it. And you'll still get half credit. Okay? All right, number 12. Or number 17. Simplify. Square root.
Wait, so like, what about is this 16?
Oh, yeah.
Okay, good. Well, if you want to make it extra credit too, yeah, I'm fine with that.
16. All right, what do you do with exponents raised to exponents? Anyone remember?
No.
You multiply them. Powers raised to powers, you multiply. So you get x to the ab plus 3a times y to the ab plus 4a all over And then all I'm doing is distributing that a to both. So you're multiplying those together. And then what I'm going to do is I'm going to bring this guy upstairs because it's got a negative exponent. So I'll just put an x to the a up here. And then I'm just left with, let's just bring them all up. Because then we can combine those. Okay, everyone okay with that? You see what we did? So we did two things. We multiplied the exponents because they're power raised to power. And then we brought up the denominator and changed the sign of the exponent. That's all legal. So now how do you multiply exponential expressions? What do you do with the exponents?
Combine them.
Yeah, well, what do you mean combine?
Or
Like terms?
Well, they're not like terms, but you're multiplying. So you're multiplying exponential expressions. What do you do with the exponents? What do you do with these exponents? Whenever you forget, do this. X squared, y to the third, x to the fifth, y to the eighth. You add the exponents. Okay, so whenever you forget the rule, just go back to algebra 1 and write an algebra 1 problem, an easy one. And then, oh yeah, you add the exponents. So I can do that with variables. So this is x to the ab plus 3a plus a. Ooh, those will combine. And then y to the ab plus 4a plus negative 2a. See what I did? I just added. So these combine and these combine. So your final answer is x to the ab plus 4a, y to the ab plus 2a. See what I did? Okay, good, good. Number 17. Simplify square root of 50 h to the 15th. Okay, so remember, this is what we started talking about a little bit on Tuesday. Let's separate this into squares versus non-squares. What is the biggest square that goes into 50? What is the biggest square that goes into 50?
25 and 2.
25, and then the 2 would go over here, right? Okay, what about the biggest square that goes into h to the 15th? So don't look at that, because when you're dealing with exponents, the biggest square is the biggest even number, right? So this is h to the 14th, because you can take the square root of that. What's the square root of h to the 14th?
7 and 2.
Just 2. The square root of h to the 14th is just h to the 7th. Because, I mean, you could think about it like fractional exponents too. This is h to the 14th over 2, or the 7th. So then you're just left with 5 h to the 7th, all times the square root of 2h. Okay, so first up, break it up into squares versus non-squares. These are the ones that are going to get stuck in that, be left in that square root sign, because you can't take the square root of anything in there. These are all the squares that you can take out. So when you're looking at numbers, you look at that list. The biggest squares that'll fit in there. When you're looking at variables, you just think of you just go to the highest even number that is underneath 15. So h to the 14th. So see how h to the 14th times h is h to the 15th? So the biggest square I can divide out of that is h to the 14th. Okay. And when you take the square root of an exponential expression, you just cut the exponent in half. All right, next, number 18. Simplify. Those things are just confusing. I mean, that's somewhat helpful, but just ignore that, please. How do I rationalize this? Because remember, you can't have a radical in the denominator. So what do how do I bust it out of there? What do I do?
Something with a negative, right?
No. In the past, we've had just stuff like that. 8 over radical 7. How do you get rid of that radical? Because you can't have radicals in the denominator. You can in the numerator, that's fine, but not in the denominator. So how do you get rid of it? How do you cancel a radical? How do you cancel a square root? Square. So we're going to square radical 7. Does that look familiar? No? Okay, let's try this. So how do you get rid of that radical 2? What do you do?
Do it.
Radical 2. And whatever you do at the bottom, you have to do to the top. So radical 2 times radical 2 will equal 2. And you solved your problem of having a radical in the denominator. Now you have a radical up top, but who cares about the top? Okay, so if we're just wanting to get, we don't care about the 3. The 3 is okay down there. But we just want to get rid of the radical 7. To get rid of a square root, you square it. So squaring radical 7 means multiplying it by radical 7. Okay, whatever you do to the bottom, do to the top. So you get 8 radical 7 over, what does this equal? What's radical 7 times radical 7?
7.
7. 3 times 7 is 21. You're done. Okay, see if you can reduce 8 and 21. You can't, so you're done. All right, number 19 is graph that. So, this is helpful. We're going to go negative b minus 2a. What's a, b, and c? Remember, a is the coefficient of the x squared term, b is the coefficient of the x term, and 2 is the constant, or c is the constant. So negative b over 2a is positive 4 over 4, or over 2 times 1. So this is just 2. So the axis of symmetry is at x equals 2. So 1, 2. This is my axis of symmetry. Right? So far, so good? Okay, so now y-intercept. So just to find the y-intercept, did we not do this? Oh, this was a long time ago, 27, I guess. To find the y-intercept, a y-intercept is where x equals 0. So set x equal to 0. So then I've got 0 squared minus 4 times 0 plus 2. Okay? So that's just 2. Y equals 2. This is also 2. So basically, you've got your y-axis intercept right there. So that's where your parabola is going to cross that. Okay, now 2 additional points. Can you think of 2 other points that would work? Let's just pick x's and y's. Let's pick x equals 1. When x equals 1, what does y equal? 1 squared minus 4 times 1 plus 2. So when x equals 1, y equals 1 minus 4 is negative 3 plus 2 is negative 1. So there's 1, negative 1 right there. Let's pick another x. Let's go past our axis of symmetry. Let's go to like x equals 3. If x equals 3, what does y equal? Well, 3 squared minus 4 times 3 plus 2. 9 minus 12 is negative 3 plus 2 is negative 1. So we got 3, negative 1 is another point. 1, 2, 3, negative 1. So it looks like this is going to be our parabola. So once you get here, just roughly draw a parabola and you're done. Okay? Now, technically, you don't have to find the axis of symmetry. You don't have to do any of that. Just pick x's and y's that will work. So the best way to do that is pick x's, figure out what y it spits out, graph those individual points, connect the dots, and you're done. Knowing that it's going to look like a parabola. Okay? I don't think it's even going to ask you for the axis of symmetry. Maybe it will, but to find the vertex is basically 2, negative 2. But if you pick that, I mean, if you just pick a bunch of points and figure out where that vertex is, you don't have to do any of those formulas or anything like that. You don't have to worry about that. Okay, last is number 20. Number 20. Bag contains 5 red, 20 blue. What is the probability of picking out a red marble, keeping it out of the bag, then picking another red marble? Okay, so this is without replacement. So red, then another red. So what's the probability of picking that first red marble? 5 out of the total number, which is 25. And then you've kept it. So you're going to multiply that by how many reds are now in the bag? 4. And how many total are in the bag?
24.
24. Okay, so that can reduce to 1 and 6. So your final is 5 over 150. This can reduce to 1 and 5, sorry. So you got 1/30th. You don't have to cross reduce before you multiply, just multiply, and then you can reduce. You get 20 over 600, which is 1/30th. Okay, that's 1 through 20. Any questions about this before I go and try to do 1 through 6?
Did you mean to put the negative?
Where?
30. I mean 20.
On 20? Where's the negative? I don't see a
On
negative.
negative 1.
Oh, sorry, I just was erasing and then it erased
Oh, there
part
we
of
go.
that.
Okay, there we go.
Yeah. Okay, so I'm gonna, you guys can, if you guys could be quiet so I can record the first, whatever I missed, that would be awesome. So. Okay, number 1 is basically just a 30, 60, 90 triangle. So if this is 20, this is 10, that's the shortcut. The short leg is always half the hypotenuse. And then this guy is just tag on a radical 3. When you did that, can you guys help me out with the answers if you have those answers? When you multiply that, I think it's like 17.3, which is just 17 centimeters because it says they're round to the nearest centimeters. Okay, number 2, factor. First step of factoring is take out a greatest common factor. And the greatest, and this is a 6, but I'm going to make this, I want to make sure my biggest exponent is positive. So take out a negative 6 and you get 3x. Oh, and x squared goes into both of those. So when you're looking for greatest common factor of variables, you're just looking for the smallest exponent. Take out a negative 6x squared, you get 3x minus 4, and that's it. Okay. Number 3, find a combination. They already wrote the formula for you, so all you have to do is do the math. So combination of 9, 6 is 9 factorial over 6 factorial times 9 minus 6 factorial, which basically is 9 factorial over 6 factorial times 3 factorial. You can just put that in your calculator, or you can realize that that's 9 times 8 times 7 because the 6 factorial up here will cancel with that, and you're just left with that math problem, which is just 84, I think. Number 4, increasing by 140%. So find 140% of 520 and then add it to 520. So what was that? 12.
Well, 728, and then you add.
728, and then you add it to 520, which is 1248. Thank you, Delaney. All right, and then number 5. Is divide. So copy dot flop x squared plus 4x over x plus 3 dot flop. So flopping the whole number means 1 on top. 8x to the 4th plus 32x cubed. Okay, first step factoring, take out a greatest common factor. This one you can take an x out and you have x plus 4. You can take an 8 and an x cubed out of this one. You're left with x plus 4. Okay, so now here's what cancels. The x plus 4's cancel. And then one of these x's cancels. But this x cannot cancel with that because the x is not a factor. You can only cancel factors. X plus 3 is the factor. So your final answer is everything cancels on top. So 1 over x plus 3 times 8x squared. You can just leave it like that. That's fine. All right, number 6, synthetic division. So the hardest part of this is remembering what to do where. So we're going to rewrite with coefficients. Here, 2, -4, 3, -6. And then the divisor is the opposite of what's being subtracted. What's being subtracted. So +3. Okay, first step, bring down the 2. Next step, multiply by 3. Put it there and then add. Multiply by 3. Add. Multiply by 3. Add. Okay, then fill in your variables. So you're going to start with just one less than what you started with, x cubed. So now it's x squared, x squared, x, and then constant, and then here's your remainder. Remember, you put your remainder over your divisor, which was x minus 3. Put addition signs in between and you're done. Okay. I don't remember where we started recording.
7 or 8.
Okay, good. Well, let's do 7. 7 is absolute value inequality. So you have to make 2 inequalities out of this. Just the version without the absolute value sign looks like this. And then the other version is without the absolute value sign, but flip the sign and negate the other side. Okay, so now we're going to solve for these equations. Let's do them at the same time. So you get -2x is greater than or equal to -4. -2x is less than or equal to -10. Divide by -2. When you divide by a negative number in an inequality, you have to flip the sign. So x is now less than or equal to 2, and x is greater than or equal to 5. So to graph that, put your 2 and 5 on there. Then you have to do this. So I'm going to shade to the left of and on top of 2. Shade to the right of and on top of 5. Okay. I think that's it. Good job.